Hello, today we're going to be showing off the TCM-U2 and its new features in terms of its menu display, just released in July of 2013. This is a TCM probe. It has the foot on right now. You can screw this off to show you without, and you can actually use it like this. Here's the diamond tip. Screw it back on again. This is for doing flat surfaces, obviously. If I screw off the base here, I can turn this around, and with the V-groove you can do round parts because you can seat it very nicely with this for doing round parts for testing. This particular probe is the 10N probe, so it requires about 2 pounds of force to activate it, and we use this little puck or foot here. So to do a test, I press down. It's a two-step thing. There's the resistance and the spring first and then second, and this is as simple as the motion is. So this allows us to keep it very steady because ultrasonic testers of course are all based on the principle of the diamond tip, which is a Vickers diamond going onto the part, vibrating at a very, very high frequency. So we've got to make sure that our probe is perpendicular to the part. It can be of course in any orientation, even upside down, but when the test is done it's going to be perpendicular, and again the motion pushed down and so on. So I have 3 NIST certified calibration test blocks here. This is a 23.17, 47.3 and a 64.3. Other test blocks are shown over here for Brunel and so on. This tester can be calibrated and needs to be calibrated for Rockwell C, Brunel and Vickers. Now with calibration test blocks, on the side of these blocks it will show you the test value. This is this 47.3, and then it's plus or minus 1 HRC, so very accurate, but we do have an error in the test block, of course, based on the hardness or the mean across. And with these test blocks comes the NIST calibration certificate. This is one that I printed out, and it shows that when this was tested, the first reading was 47.2, 47.21, 57, and so on. And so that the mean hardness is 47.3 with a variation of plus or minus 1. Now when we're doing the calibration, this is the new menu display that we have, and it's as simple as scrolling along using this up and down arrow keys. So here we are right now, it's on calibration. This would be for measuring. This is information, and you can see this is our information at our company. This is the back button, so it takes us back up again. If I scroll on further, the memory card, and in the test probe there is a memory card because we actually store the calibrations in the probe, meaning that probes are interchangeable with the tester, kind of unique and very special. Settings for the probe itself and for the display, so we can have it so that we can have a power off value and so on. If we look at this, for example, here is the measurement settings. We hit the select button, and here we can show the current result or the last result. The tolerance specified for doing smart testing, which means that if each test, if one is a large aberration or outside of the range, it will automatically delete that within 7%. The material I'm testing to is alloy steel, and retro means we want to show the last test result automatically on the display. So I can hit the back button here or change these values, and I'll leave this as being off. The back button, if I go into settings again here, I can then use the arrow keys and do the device settings. So if I click on select, I've got the language in English, the brightness is displayed as 100, which is maximum. Do I want to have the key beeps off or on, and so on. I hit the back button again, so it's really just these 2 main buttons that are used, select and back and so on. Now one of the key things you need to do when the tester is received is to go to the memory card. We do this before we ship the product for you, but it would pay to repeat anyway. Go to memory card, hit select, and we want to create a backup copy of the calibrations that are on the probe. So if we hit the select button here, and we say yes, now it's copied the calibrations that are stored in the probe and put them into the device. If we hit the back button, we're now going to do a calibration. So if I scroll back to calibration, we're on the calibration display, hit the select button, and you can see here we have the scale, so hardness and Rockwell C, Brunel, Vickers, and we have even a user defined. We can store this as just steel, or AST as alloy steel, stainless steel, and then 2 user defined ones. So you could do, say, titanium or some exotic material if you wish to. We do pre-calibrate the units with for Rockwell C and Brunel for just low carbon steel or mild steels. What I'm going to be doing here is calibrating the unit for high carbon steel using my calibration test blocks. So you can see I can move my cursor around, and this will be choosing to create a calibration, in this case here, for steel and Rockwell C. I don't want to overwrite the current calibrations, I want to create a new one, so I go over that field and I hit select. I want to do edit, so I hit the same button again. And now what I need to do, you can see this is the nominal value is showing 200. I need to change the value to whatever the test block is. And you can see the test block here is 23.17. So I need to come into this, hit edit. And I want to edit this value, so I say edit. And the display with the background clears off. I want this value to be 1, so I just go down to 1, hit edit, jumps across to the next value. I'm going to put in 23, 2, edit, 3, edit, and it's 17. The tolerance within our tester is plus or minus 1.5 or 2, so we don't need to have that last value. I'm going to call this a value of 2, because it is on the test block, it's actually called out as 17. And I hit the edit button, it goes, background is all shown. I can now go to the next one and I hit edit, and what I want to do here is my second test block in my range is 47.30, and so here 47.30, I'm now going to change my values for this to be 47.30, so here we go to 0, edit, up to 47, edit, edit, and then we're just going to put in the value of 3. It goes background onto the third one, which is we do 3 in the range, make sure we're covering the whole range for our hardness testing for this particular material of alloy steel. I hit the edit button, and I put in the value of this one. Our last test sample is 64.31. So zero this out, edit, 64, and we'll put in a value of 3 here. Okay, so these have all been zeroed out. Now what I can do is come back here to my first one by scrolling over it, and all I need to do now, you see the code is showing as 0, is to do several tests. So there is 1, 2, 3, 4, 5. I go down to my next one, 1, 2, 3, 4, and then to the next one, 1, 2, 3, 4. No, I'm going to do 5 here because I wanted to average these out. Okay, and so now you can see our code. We just hit the back button right now. It says, do I want to save my new calibration? I say yes. And there it is saved, and you can see here that now I have a little rectangle showing under Rockwell C that I've created for calibration. So now I can go back to my main screen, and what I have to make sure of is that when I'm doing my test, under measuring here, if I hit select, AST is shown and I'm in Rockwell C. I can change that scale to other scale types here. Alright, but of course I'd have to have those calibrated as well. Let's go back to HRC, set that. Now to set the material type, we saw this before, I'm just going to hit the select button here and I want to exit out of that. And I need to set that because typically you're going to be measuring one type of material, you won't be bouncing around from one to the other to the other. And under the settings area, I hit select, and you can see here that I have AL steel or alloys steel, so I'm actually at the correct setting. The other thing I might want to do at this stage is to save back to my memory card, in other words to save these results back to the probe itself because it has its own memory, is to use the arrow buttons and do a load backup copies of calibration. This first one here is to create a backup copy of calibrations. Hit select, so it's the first one in our line here. We hit save, and now we've saved to the probe the calibrations for these test blocks. So it's as simple as that. Thank you.